everyone, I welcome you to the continuation of the sine and cosine rule. In this particular video, we're going to focus on the cosine rule. So without wasting much of our time, we need to ask the question, where can it be applied? Where can it be applied? That's the most important question that we are supposed to answer. First, it can be applied where three sides are given. Secondly, it can also be applied where two sides, let's say two sides and an angle are given. So where those have been given, it makes your work easier for you to use the cosine rule. Okay, so let's move on to this page. So now let's start with a simple triangle. We'll name it triangle ABC. So we'll name that one A, that one B, and that one C. So how you name your sides, it doesn't really matter, because sometimes they can be given different names, sometimes they can be called QRS or STU. It doesn't really matter. So first things first, we need to turn this triangle, or we need to find a way in which we can find at least a right angled triangle inside this given triangle, which is triangle ABC. So why should we find a way in which we can do that? It is because it is easier for us to deal with right angled triangles, because we could easily use the Pythagoras Theorem or the trig ratios. Hope we still remember this, the trig ratios. Okay, so we've got sine theta is equals to opposite over hypotenuse, cos theta is equals to adjacent over hypotenuse, and tan theta is equals to opposite over adjacent. So these are the trig ratios. So the main reason why we have to turn this into a right angled triangle, like I said, I'm repeating, it is because it is easier for us to work with right angled triangle. So this one we can simply name it H because it is the height. The opposite of A becomes A, the opposite of C, C, and we have the down part which becomes B. So the first thing which we are going to do is we are going to apply Pythagoras Theorem. We're going to apply the Pythagoras Theorem, but in order for us to apply this one, it will simply means that we need to know this side, the length of that side and the length of that side. So we are going to name this side Y. So at the moment we name that one Y, this one becomes B minus Y. Okay, so now we are saying this one, let me just drag it down here, we are saying this one becomes B minus Y, since we know the other side being that. So now applying what we have here in Pythagoras Theorem, let's start with the first triangle, that is BCB. So we are going to say, according to Pythagoras Theorem, which says C squared is equal to A squared plus B squared, of which we know that C talks about the hypotenuse. So we're saying the hypotenuse squared is equal to the base squared plus the height squared. And then when we are to look at the other triangle here, which is triangle BBA, what we are going to have this side, we're going to have the hypotenuse squared, which is C squared, is equal to the base squared, that is B minus Y squared, and plus the height squared. So what we are going to do with this side, we're simply going to make H the subject of the formula, and this is going to become that So meaning this is the value of y. So the main reason we are doing this, it is because we want to substitute the value of h into the other formula which we have right up there, and this is what we are going to have now. So we're going to say c squared is equal to b minus that squared plus h squared. So here we are saying we substitute with the value of h squared. So we are saying h squared is simply equal to a squared minus y squared. So having reached here, we are going to expand that one there. So we know that in expanding that one, we are saying that is open bracket b minus y, open bracket b minus y, and we are going to now multiply b multiplied by b gives us b squared, b multiplied by negative y, it gives us y, and that again it gives us that, and now it gives us a positive y squared. So we are saying this is the expanded view or the expanded way of what we had here, that is the b minus y squared. So now here my work is a bit messy, but I hope we are able to follow. So here we're going to say c squared is equal to, so this now becomes b squared minus 2by, because we had two of them there, b negative by minus by, it gives us negative 2by, like that, plus y squared plus a squared minus y squared. So we see that this one and that one will cancel out, this being positive and that being negative, so they'll go. In short, we are saying y squared minus y squared, it gives us nothing, so it will die out. So here we have c squared is equal to b squared minus 2by plus a, of which the a has been squared. But now we see that we cannot conclude here, because we are still remaining with something that originally was not there in the question, which is y. So for us to settle, we need to find what is the value of y. So again, I'll separate my work like this. So come on the other side in order for us to find the value of y. Or let's just do this. Let's just clear this other screen so that we can find the value of y. So move this slightly there. So looking at that, if we are trying to find the value of y, since this is a cosine rule, we're going to use cos theta, which is cos c is equal to, now remember, cos theta is equals to adjacent over hypotenuse. So cos theta is equal to, what is the adjacent? The adjacent is y and the hypotenuse is a. So now when we cross multiply, we are going to have a cos c is equal to y. Therefore we are saying this is the value of y. So we again going to substitute that one into our formula. Therefore we're going to have c squared is equal to b squared minus 2b, then what is y? We open bracket cos c plus a squared. So having reached here, we simply group what seems to be alike. So this becomes c squared is equal to, what do we have again? This becomes a squared plus b squared minus 2b cos c. So if we are to rewrite this properly, finally it will now give us c squared is equal to a squared plus b squared minus 2. Now we left out something here, which is that one. Okay, let's just go back. We left out something here, which was the a, which we're supposed to have, which is that one here. So we are simply saying let's just put that one back where it is supposed to be. Much better. So when we come here now, this becomes ab cos c, and therefore now we can conclude to say c squared is equal to a squared plus b squared minus 2ab cos c, and we are saying this is the cosine rule. And remember earlier on we talked about the sine rule, and we said the sine rule will be a over sine a is equal to b over sine b, which is also equal to c over sine c. And for the cosine rule, so we are saying the cosine rule can actually be presented in a number of ways. It can be the same procedure which we have done. It can be presented as c squared is equal to a squared plus b squared minus 2ab cos c. Or if you're finding the other side, which is b, it becomes b squared is equal to a squared plus c squared minus 2ac cos b. And when you're finding the other side, which is a, it becomes a squared is equal to b squared plus c squared minus 2bc cos a. So meaning we can use any of these to find out any of our missing sides in any given triangle. So whether we've been given something like this, we are still able to find the missing sides, and that is how the cosine rule is derived, and that is how it can also be applied. So in application, the same way the sine rule, it can also be applied. So what is just required is for you to be able to identify the sides and the given angles. Okay, that's all for now.